Welcome to the Walton Pi. Today we're going to go through some examples of using the chain rule, as well as why this is going to be something that's going to show up on your test. No matter who your professor is, it'll show up. Let's suppose that we have f of x is equal to sine of tangent of cosine of x. Is that the right number? Nope, that's one too many parentheses. So let's say that that is what f of x is. Let's figure out what is f prime of x. Well, we are going to be working our way from the outside to the inside. So we are going to say, what is the derivative of sine? Well, the derivative of sine is cosine, and we are going to leave the inside alone. So that is going to be tangent of cosine of x. The inside stayed the same, but then we are going to multiply by the derivative of that inside piece. So then we have a tangent come out, so the derivative of tangent, that is a secant squared. So it's secant squared of the inside, and that's going to stay the same. So we will have secant squared of cosine of x. But then we have to take the derivative of that inside. So the derivative of cosine, that is a negative sine of x. And then the derivative of x, that's just a 1, so that means that we are done. We have successfully finished this chain rule. So that is how we would figure out the derivative of that. If we had a different function, suppose we had f of x is equal to 3x minus the square root of x squared minus tangent of x plus 13. If we had this, then the derivative would be f prime of x is equal to the derivative of our first piece, so the derivative of 3x is just a 3, and then we have a chain rule problem here. So the derivative of the square root of something is 1 over 2 times that square root, so 1 over 2 times the square root of x squared minus tangent of x plus 3, but then x plus 13, sorry. But then we have to take the derivative of that, so the derivative of the inside piece, that is going to be times 2x, derivative of x squared is 2x, minus the derivative of tangent is secant squared, so secant squared of x plus 13. X plus 13 is a function inside of tangent, so we have to multiply by the derivative of x plus 13, which in this case is just 1. And so that would be what this derivative would be. However, if we had changed this slightly, so it was x squared plus 13, then this would be an x squared, that would be an x squared, and then the derivative of x squared plus 13, that would be a 2x. And so that would be our derivative in this case. Now, as I said at the beginning of this video, the chain rule is something that your professor will probably almost certainly put on most tests that will test you on knowing your derivatives, because you can put all the different functions together. So for example, they might ask you if f of x is equal to sine of x cubed minus e to the 7x plus the square root of tangent of 3x to the 4th plus 2. For example, this is a function that has trig, it has polynomials, it has exponentials, it has square root, and it has a whole bunch of chain rule all nested together. So this is a function that is totally doable to take the derivative of. The challenge, though, is it's tested on at least 4 different types of derivatives, not including the chain rule. So let's just go through this one as our final example. So if we look at what is f prime of x going to be, well, the derivative of our outsidemost function. So that is going to be this sine. The derivative of that is cosine, so we get cosine of and our inside does not change in this part. So cosine of x cubed minus e to the 7x plus the square root of tangent of 3x to the 4th plus 2, then we multiply that by the derivative of the inside. So the derivative of x cubed is 3x squared. The derivative of e to the 7x is e to the 7x. So is 7e to the 7x. And then the derivative of the square root, that is going to be a 1 divided by 2 times the square root. So tangent of 3x to the 4th plus 2, multiplied by the derivative of what was inside the square root. So the derivative of tangent is secant squared of the inside, so 3x to the 4th, multiplied by the derivative of 3x to the 4th, that's a 12x cubed, and then derivative of 2 is 0, so that is all that we have there, and that has finished all of our nesting. So that whole long thing, maybe with a little bit of simplification, but I would probably leave it at that, that is the derivative of f. It's complicated to do, and you have to be very careful in keeping track that you are including all of the different pieces, but that is how we can be able to figure that out. I just realized that I did skip over how I got this. When we are taking the derivative of e to the 7x, we can think of this as e to the f of x, where f of x is equal to 7x. So if we are taking the derivative of e to the f of x, that is going to be e to the f of x times f prime of x. And so that's where we're getting e to the 7x times 7, because 7 was the derivative of 7x. So that's how I got this piece. But again, all of this is just using the chain rule and the derivatives of sine, cosine, square roots, e to the x's, all the different functions that we have. We are just using those and the rule of the chain rule to be able to take derivatives of fairly complicated functions. I hope you enjoyed this video and that it was helpful for you. Please check out some of my other videos, and please like and subscribe if you have not already, so I can continue to make these sorts of videos. Have a great day and good luck with the rest of your math.